If you demand hot performance and superior handling, you need a high-performance polygraphite front-end kit. PST's exclusive high-performance polygraphite bushings are made with high-tech polyurethane designed for street, strip, or track cars. Polygraphite bushings virtually eliminate the cornering deflection associated with stock rubber bushings. Get precise handling and control with polygraphite components from PST. PST's exclusive polygraphite bushings are so superior to other products that we offer a 10-year warranty. Each order from PST is shipped free to 48 states. So call our toll-free number to order your polygraphite front-end kit today and ask for our free muscle car catalog. Polygraphite, a PST exclusive, the ultimate in suspension technology.
Hi, I'm Greg Colletti. Welcome to American Muscle Cars, Volume Number 4. In this production, we're going to give you a hands-on, step-by-step journey through the disassembly, reassembly required to rebuild a AA-arm coil spring front suspension. We're also offering technical highlights on other types of popular front suspensions. These are the components we'll be working with when rebuilding our front suspension. First, let's take a look at the sway bar or anti-roll bar and the fact that it is attached to the chassis in two locations via a bushing and bracket assembly. Next, the sway bar is attached to the lower control arms via the link bolts. The link bolts consist of a long through bolt with a spacer and multiple washers and bushings. Next, we have our tie rod assemblies, which consists of an outer and inner tie rod, an adjusting sleeve, and locking clamps. We also have our shock absorbers and mounting hardware. We have our steering knuckle assembly, which consists of the spindle, the knuckle mount, which attaches to the lower and upper ball joint, our steering or knuckle arm, which attaches to the steering linkage via the tie rod in this location. We have coil springs, lower control arm assemblies, left and right, which consist of the control arm itself, the lower ball joint and hardware. On some applications, a bump stop, and the front and rear lower control arm bushings. Next, we have our upper control arm assembly, left and right, which consist again of the control arm itself, the ball joint and mounting hardware. An upper control arm shaft assembly, which consists of the shaft, bushings, and retaining hardware. In the upper control arm area, we also have a bump stop, which in some applications mounts below the upper control arm to the chassis, and in other applications mounts directly to the underside of the upper control arm. During disassembly, pay particular attention to the positioning and location of all components. These components must be reinstalled in the original position and location during reassembly. Now, let's look at all the replacement parts we're going to use to rebuild our front suspension. Here are all the new parts we're going to use in our front end rebuild. We have shock absorbers, sway bar bushings and mounting brackets, sway bar links, inner and outer tie rods, adjusting sleeves with clamps. In the lower control arm, we have new bump stops, front and rear bushings and ball joints. In the upper control arm, we have new ball joints, shaft bushings, and bump stops. We are using performance suspension technologies, polygraphite bushings in our front end rebuild. They are a premium polyurethane bushing and a vast improvement over the stock rubber bushings. Next, we're going to show you some special tools required to perform the rebuild. Here are the special tools required for the front end rebuild. First, we have the tie rod assembly as it was removed from our vehicle. We're going to use that to set the length of our new assemblies to aid us in realignment. Next, we need a coil spring compressor that is designated for your application. This is a ball joint fork, which we use to separate the ball joints and the tie rods. And here is an economical substitute for expensive professional bushing and ball joint drivers. To install the lower ball joint in this application, the ball joints are pressed into the control arm. To do that, we need a tool that will locate itself around this area of the ball joint without contacting the soft center. This pipe bushing lends itself readily to this application. We need this block of steel for all our bushing driving to span across our installation tool so that when we strike it in the center with a hammer, it spreads the applying force evenly around the component. Next, we have a bearing race that we're going to use to install the upper control arm bushing. The bushing must be installed by applying force to this rim around the bushing sleeve without contacting the soft polyurethane insert. This particular bearing race does that very nicely. It contacts the sleeve and locates us on the bushing. For the lower control arm bushing, we don't have a very big sleeve to contact. However, this bearing race that we picked out of our garbage bin fits this application very nicely also. The last economical but exotic tool you'll need is the memory tape. The memory tape is simply a piece of duct tape that we've marked left and right side on. This is going to be for the upper control arm components related to the shims to be redeposited back in their original location to aid in final alignment. This is where our front shims will go from the upper control arm on the left side and the rear shims. Consequently, the right upper control arm, these will be our rear and front shims. The S mark down here is going to be for the compressed length of the coil spring from that side. So when we go to reinstall the spring, we know how far to compress it to aid in proper reinstallation. Next, we're going to have a few tips on safety. There are 6 basic rules to follow when using a spring compressor. First, make sure that the compressor you're going to use is of proper design for the application. 2, before using the compressor, inspect it for proper safe condition. 3, before you compress a spring, make sure that the compressor is installed properly. This means that the spring is fully engaged by all fingers of the compressor. 4, never compress the spring more than necessary to facilitate proper removal and reinstallation of the spring. 5, never leave the spring loaded with the compressor any longer than absolutely necessary to do the job. 6, and most important, never have a loaded spring facing you or anyone else. Always make sure that the ends of the springs face away from you. If the compressor were to fail while the spring is loaded, the spring is going to jump across the room or in any direction. You want it moving away from you. Next, we'll look into another safety tip. This is a lower control arm bolt. It's not new, it's used. However, the whole shank area of the bolt and thread area is in perfect condition. This bolt we can reuse. Now, let's take a look at a bolt that's been eroded over time. This bolt is deeply pitted and the threads are distorted. This bolt should be discarded and another bolt that was designed for this application should be installed. If this bolt were to fail, your front suspension would also fail. Always check your hardware before reinstallation. To safely raise your vehicle, consult your owner's manual for proper jacking points. When using a floor jack to raise your vehicle, raise it from the frame or cross member. Always use support jacks under the vehicle before working on it. Always use support jacks in pairs. At no time ever rely on the jack alone. At no time ever use cinder blocks to support your vehicle. Throughout this project, you're going to be working with hammers, chisels, and in very dirty areas. So at all times, you should wear proper eye safety equipment. Enough said. The anti-roll bar is connected to the chassis at two locations with a metal bracket and accompanying bushing. The bracket's held to the chassis in the front and the back of the bushing with bolts. The anti-roll bar is then connected to the lower control arm via a link assembly. Mounted to the bottom of the lower control arm with two bolts is a shock absorber which can be seen running vertically through the spring. The top of the shock is mounted to the chassis with the nut and bushing assembly. The coil spring is located between the chassis at the top and a matching area in the lower control arm. The lower control arm is mounted to the chassis in the front area and the rear area of the lower control arm with through bolts. The steering knuckle is attached to the lower control arm via the lower ball joint. The steering arm is attached to the outer tie rod at this location. The tie rod continues in toward the center of the vehicle through the adjusting sleeve, continuing through the inner tie rod, which attaches in this area to the remainder of the steering linkage. Here's a top view of our suspension and steering. Take note of the anti-roll bar attaching to the lower control arm through the link, the tie rod adjusting sleeve, the outer tie rod, where it attaches to the steering arm. The steering arm is bolted to our spindle assembly. The spindle assembly at the top is attached to our upper control arm at this location through the upper ball joint. The upper control arm is attached to the chassis via the upper control arm shaft assembly, and it's attached to the chassis with two stud and nut assemblies. At this location, we're actually looking at the top of the shock absorber, the attaching nut, upper washer, and bushing. Turning our front wheel, we'll get a better view of the brake caliper and its mountings in relationship to the spindle. From this view, we can witness our brake caliper. It is attached to the steering knuckle through a mounting bracket by two bolts, one located at the top of the caliper and one at the bottom. A good place to start is removal of the sway bar. In order to remove the sway bar, we're going to first remove the links at both ends and then the mounting brackets to the chassis. To remove the link, we take the nut off the top, pull the link assembly away. Next we'll take our wrench, remove the mounting bracket from the frame on both sides. Before final removal of the last mounting bolt to the frame, support the sway bar so it doesn't fall. With the mounting brackets disconnected, we simply remove the sway bar. Next, we're going to remove the entire tie rod assembly. To do that, we have to first remove the cotter pins from the inner and outer nut, and at this time also remove the cotter pins from the lower and upper ball joint to facilitate their removal later. Next, we remove the nuts, and by using our ball joint fork and a hammer, we will remove the tie rod assembly from the vehicle. This is our entire tie rod assembly. Do not discard it because we're going to want to measure it out to preset our new assembly for proper tow. Next, we're going to remove the brake caliper. To do this, we're going to remove the upper and lower attaching bolts, pull it away from the rotor, and then with a heavy piece of wire, we're going to hang it anywhere within the wheel well to the back of the wheel well to keep it out of our way, and also to keep the weight of the caliper off of the flexible line to keep from damaging it. Next, we want to remove the shock absorber. We've already taken the nut off the top of the shock absorber. Now, we have to remove the two lower attaching bolts and pull the shock absorber down through the lower control arm to complete removal. Now, we want to loosen the front and rear lower control arm mounting bolts a few turns so that when we go to remove our spring, the control arm will swing away freely out of our way. We also want to loosen the upper and lower ball joint nuts one turn, after which we take a large hammer and strike the spindle here and here until the ball joints pop loose. Now it's time to install our spring compressor. To do that, we have to install it up through the lower control arm, position it in the spring, and properly engage the spring with these hooked feet. The spring compressor is properly mounted in the spring when the top end of the compressor is as close to the top of the spring as possible, and the bottom of the compressor is located as close to the bottom of the spring as possible. Always be very careful to properly locate the spring within the compressor fingers. Now it's time to use a coil spring compressor to compress the coil spring. To do that, we're going to use a ratchet and socket assembly through the lower control arm, tightening the compressor only until the spring becomes loose in its confines and no more. Never compress the spring more than absolutely necessary to do the job. Next, we're going to position a floor jack from the opposite side of the car underneath the lower control arm and raise the control arm up approximately 1/4 of an inch. Now we can safely remove the nuts from the upper and lower ball joint and remove the entire spindle assembly from the vehicle. After which, we're going to slowly lower the jack, allowing the lower control arm to swing down slowly, allowing us to remove the coil spring. Once the spring is out, you always want to make sure, once again, that the ends of the springs are not facing towards you or anyone else. If the spring compressor were to break, if it's facing towards you, you have a very good chance of getting hurt. Before unloading the spring, we first want to mark the location of the compressor for reinstallation purposes and also the compressed length of the spring to facilitate reinstallation. We need to take our grease pencil and mark on the spring the location of all the fingers of the compressor. We want to reinstall the compressor in the spring in the exact location so we don't have an interference problem during reinstallation. We also want to measure the compressed length of the spring, which in this spring we have 13¼ inches. And then for that side of the vehicle, we're going to record that length on the memory tape so that the spring will go back into the vehicle easily. To remove the lower control arm, simply remove the 2 attaching bolts. To remove the upper control arm, we must remove both attaching nuts, the shims, and then remove the studs themselves on the driver's side because the steering shaft is in our way from removing the control arm. Usually on the passenger side, it is not necessary to loosen or remove the studs. When we first loosen the nuts, the shim packs will become loose. We want to remove these shim packs in their entirety from the rear and the front and attach them in the corresponding location on our memory tape so that they can be reinstalled in their original location to aid us in establishing proper pre-alignment. With the nuts backed off to the end of the stud, to protect the end of the stud, but at the point where you can move them with your fingers, you're going to have to take a hammer or a bar and striking the end of the nut, push the stud in through the mount. Now, by removing the nut, we can remove the control arm. This is our upper control arm. During reassembly, once the control arm is located back in its proper position, we're going to lift up on the control arm to expose the head of the studs, using a punch and a hammer, drive the stud back into position into the mount to engage a spline so we can reinstall the control arm mounting nuts. With removal of the bump stop, chassis disassembly is completed. On this application, we need to just twist it to break it loose and then draw it out of the hole in the chassis. Some stops may have a stud through the bottom held in by a nut. The nut must be removed to facilitate removal of the bump stop. To prepare the sub-assemblies for the new components, we must remove all bushings and ball joints from the control arms. We're going to start by removing the bushings from the lower control arm. We have found that the simplest way to do this with common tools without damaging the control arms is to use a drill bit and drill through the rubber all the way around, removing the inner contents of the bushing. Then we can go back and remove the outer steel sleeve. We also recommend to lubricate the drill bit with some type of penetrating oil. You should also use a drill bit no bigger in diameter than the distance between the inner and outer metal parts of the bushing. In this view of the lower control arm, we can see the location of the outer metal sleeve of the bushing. We're going to take a metal drift and drive it into the bushing, collapsing the bushing into the bore of the control arm, and remove the bushing. This view shows the steel sleeve adequately collapsed into the bore of the control arm. Now we can take a chisel and finish removal of the bushing sleeve. This is our compressed metal sleeve after removal. On applications that use the oval type lower control arm bushings, do not remove the metal sleeve after drilling out the rubber insides. Instead, carefully clean all debris from the inside of this sleeve to properly prepare to receive the new polyurethane control arm bushing. A word of caution on the lower ball joints before removal. You must inspect the interface between the ball joint and the control arm in this area. Some manufacturers spot weld the ball joint to the control arm in this area to secure the joint to the control arm. If your application has these spot welds, the welds must be ground through and cracked before attempting to remove the ball joint from the control arm. In our application, the lower ball joint is simply pressed into the control arm from the bottom up. To remove it, we need to firmly support the control arm and, using a large hammer, drive the ball joint down through the control arm. This completes disassembly of the lower control arm. Now we're going to wash it, reassemble it, and then paint it. To outfit the lower control arm, we must install the front and rear bushing and the ball joint. To install the front bushing, we need to support the control arm under this flange. To install the ball joint, we need to support the control arm on this area. To install the oval bushing in the rear of the control arm, we need only to lubricate and press in the new insert. Before installing the front lower control arm bushing, going to lubricate the bore with a little bit of all-purpose grease. Now we're supporting the control arm from the outer flange, as mentioned earlier. Going to drop the bushing in place, making sure that the small end lines up through the other hole. Using our proper econo driver for this bushing, our bearing race, we put it in place over the bushing. Using our steel bridge, hold it in place, and drive the bushing into place with a hammer. The bushing is fully installed when the flange of the metal sleeve is flush with the face of the control arm all the way around, and the inside of the bushing projects through the other face of the control arm. To install the oval bushing, we simply need to lightly grease the metal sleeve on the inside, support the control arm from the flange, and press the bushing into the sleeve. To install the ball joint, once again, we lightly lubricate the bore, support the control arm from the opposite face, position the ball joint evenly in the bore, using our driver and our metal plate, drive the ball joint into the control arm. The ball joint is fully and properly installed when the flange of the joint is flush with the edge of the bore of the control arm all the way around. To remove the upper control arm bushings, you first have to remove the nut or attaching bolt, the encompassing washer, and then you will have access to the bushing underneath. With the nuts and washers off, we want to grab the control arm and pull it and pivot it on its support arm and lubricate these areas with penetrating oil until it moves freely. Next, we want to use a blunt chisel and strike the outer sleeves of the bushings in this area to loosen the bushing in the control arm. After which, we'll use a beveled chisel from the outside to draw the bushing and sleeve out of the control arm. We start off with the blunt chisel. Next, we use a bevel chisel that's only ground from one side. By placing the bevel against the control arm, we strike the chisel down and it will start to draw the bushing out of the control arm. We do this a little bit at a time, moving around the bushing so as to draw it evenly from the control arm. Now we can reposition the control arm and pull it off the other side. Remove the bushing shaft. This bushing can now be removed by securely supporting the control arm and driving the bushing down and through with a hammer. If your upper ball joint is held in with nuts and bolts, it has already been replaced before. Removing the fasteners will remove the ball joint. In our application, we still have the original factory rivets holding the ball joint. To remove this ball joint, we must first center punch all 4 rivets, use a 3/16 diameter drill bit to drill through the rivets, use a larger drill to remove the heads from the rivets, then we can remove the ball joint, and with a small punch, we can remove the remainder of the rivet from the control arm. Now use a larger drill to remove the head. With all the heads of the rivets removed, we must reposition the control arm to remove the ball joint. Want to support the control arm securely and drive the ball joint through with the hammer. Now, we can turn the control arm over and with our punch, remove the rivets. This completes disassembly of the upper control arm. Before installing the upper ball joint in the upper control arm, first check that the holes are large enough to fit the hardware supplied with the ball joint. Sometimes it is necessary to increase the diameter of the hole for the hardware. Do not increase the size of the hole any larger than necessary for this hardware. When installing the upper ball joint, we first want to lubricate key areas. We want to lubricate this area of the ball joint all the way around and the threads of all 4 attaching bolts. Next, we're going to place the ball joint through the control arm from the top down, slide the boot and boot retainer over the pin in place, install the attaching bolts, lock washer, and nut. Do not tighten any of the fasteners till all fasteners are in place. With all bolts in position, it's time to final tighten them. These bolts should be tightened firmly, and if you have a torque wrench with a 5/16 bolt that we're using, they should be torqued to between 15 and 18 pounds. Once these bolts are tightened, the installation of the upper ball joint is complete. This is how your installed ball joint should look. From the bottom, end, and top. To install the upper control arm shaft, we will first install 1 bushing, after which we'll take our shaft, slide it through the opposite end, through the first bushing, install the retaining hardware, followed by the next bushing and its retaining hardware. First, we lubricate the bore, position the bushing in place, use our other Econo bushing driver, the bearing race, our bar stock, and drive the bushing into place until it's seated around its lip. Now, we need to lubricate the inside of the bushing so that our shaft never seizes onto it. Install the shaft. Lubricate the threads of the shaft. Install retaining washer and nut. We don't need to tighten it at this time. Now we need to install the opposite bushing. Once again, we lubricate the bore, lubricate the inside of the bushing, position it, using the driving tool and our bridge, drive the bushing into place. If your driver isn't deep enough to clear the top of the threads, you might have to find a deeper driver. Our driver was deep enough. Now we have next to lubricate the threads and install the retaining hardware. What we want to do next is tighten the nuts just to the point where our shaft still rotates snugly. We'll do the final tightening on the upper control arm shaft nuts after the unit has been reinstalled in the vehicle and the vehicle is at ride height. Before reassembly, we thoroughly cleaned our chassis and related components. We then refinished them using Eastwood's rust stabilizer and chassis black paint. They provide us with excellent coverage and lasting protection for the chassis and related metal components. The ends of most coil springs are not made the same. In our application, the top end of the spring, the end that goes into the chassis, is wound flat, as we can see here. The opposite end, the end that goes into the lower control arm, is open wound, as we can see here. Taking a look at the underside of the lower control arm, in the area where the spring would seat, as we follow it around, we see this large bump. Taking a look at the top of the control arm, in the area that will actually be contacted by the spring, we've highlighted this area in red. This corresponds with the large bump we saw on the underside of the control arm. Is this area which the open end of the spring must be in contact with in this alignment after the spring has been unloaded and the spring is in the stages of final installation. Also keep in mind that while locating the bottom, you must retain the top of the spring by its ID in the top of the frame in the locating tabs. A note on spring installation. The top of the spring installed in the frame must be aligned so that these tabs are located on the inside diameter of the coil spring. Prior to reinstalling the lower control arm in the chassis, make sure that the contact areas of the bushings in these areas are thoroughly clean, free of rust and dirt. Next, we want to generously lubricate these areas with grease so that the bushings can slide on them. After which, we're going to generously lubricate the bolts, install the control arm into the chassis, and snug the bolts. Do not tighten them completely. We want the control arm to be free to swing, and the bolts will be final tightened after all the suspension has been reinstalled and the vehicle is at ride height. Position the control arm in the chassis. With the control arm properly positioned in the chassis and the bolt holes in alignment, install the bolts, the nuts, and just snug the bolts. Final tightening will be accomplished after the entire front end is back together and the vehicle is at ride height. We want the bolts left just loose enough where the control arm can drop by its own weight. Before installing the upper control arm, we want to first install the bump stop. To do this on our application, we've greased the bottom end and the locating pin. We're just going to put it in its hole, twist and push down until it snaps into place. There it goes. Now you can install the upper control arm. To install the upper control arm, we must first reposition the control arm around the associated mount in the frame, after which we're going to install the attaching hardware back through the frame, through the control arm shaft mount, installing our nuts and snugging into place, after which we will lift the control arm up. Using a punch and a hammer, we're going to reseat the attaching studs into the frame mount, after which we'll reinstall our shims in their respective locations as recorded on our memory tape. Be sure to thoroughly lubricate the entire length of the bolt before installation. With the nuts installed on the studs and the control arm lifted, we have access to the head of the studs. Now we can reseat them into their mount with a drift and a hammer. Now we can reinstall the upper control arm shims and tighten the control arm into position. When reinstalling your shims, make sure that the open end is facing down after final assembly. This is how the shims should appear when the control arm has been finally tightened into place. With the upper and lower control arms positioned in the chassis, you can now reinstall a coil spring. To do this, we want to first make sure that our spindle is prepared and close at hand. To prepare it, we want to grease the tapers for the lower and upper ball joint. This will assure us that they will pull in correctly. Keep that nearby. Next, we want to make sure that our floor jack is positioned under the lower control arm in this manner. We also want to make sure we have all necessary tools and hardware to secure the spindle into the car. Now it's time to reinstall the spring compressor into our coil spring using the reference marks we made while it was installed during disassembly. This will assure us that the coil spring compressor will not bind or jam anywhere during reinstallation. Next, we need to compress the spring back to the length that we recorded on the memory tape before reinstalling the spring. After which, we want to lubricate both ends of the spring with a film of grease, which will aid us in locating the spring in the chassis and control arm and limit squeaks after installation. The purpose for having everything prepared before putting the spring in is so that we can have the spring under compression the least amount of time during reinstallation. Our spring is compressed back to the disassembly length. Now we need to lubricate the spring and install it in the chassis. Once again, always keep the spring ends facing away from you or anyone else. Now, we need to raise the jack up slowly and locate the spring in the upper seat. To confirm that the spring is properly located in the top seat, you're going to have to look up into the chassis from underneath. Once you are certain that the spring is located in the top seat, Then double check the lower seat. You remember that was the area we were marked in red. Once you have verified that both ends are properly located, continue slowly raising the jack until you have slight tension on the spring. This will keep it in location for you. Next, you install the spindle onto the lower ball joint, install the nut finger tight, bring the upper control arm down, engage it in the spindle, and finger tighten that nut. After which, you can remove the jack and remove the spring compressor. With the jack holding light tension on the spring and the spring properly seated at the top and bottom, we install the spindle over the lower ball joint, install the nut, finger tight. Now engage the upper ball joint into the spindle and install that nut, finger tight. Next, snug both upper and lower nuts with a wrench. You don't have to make them tight now, just snug. Now, the jack can be removed and the coil spring compressor can safely be removed from the spring. With the spring compressor removed, we should double check the positioning location of the top and bottom of the coil spring to ensure that it is correct at this time. If not, we'll have to reinstall the compressor, remove the spindle, and relocate the spring once again. That is why we only snug the ball joint bolts to make it easier to remove the spindle in case we have to reseat the spring. Once we've confirmed that the coil spring is properly installed, we want to final tighten the lower and upper ball joint nuts and install the locking cotter pins. With the cotter pin in place, we want to safety the pin by bending the long end of it down. We want to lock the cotter pin in position by splaying the ends out to secure it in the ball joint. When installing shock absorbers, it's always good policy to lubricate the stem and all mounting hardware. This will make disassembly much easier in the future. To prepare the tie rod for installation, we want to generously lubricate the threads inside the adjusting sleeve and on the tie rod ends themselves. This will make it much easier years later to reset toe. It'll keep them from rusting up solid. When engaging the sleeve and the tie rod, we want to make sure that the thread in the sleeve is equal for both tie rod ends. To do that, we'll insert one or the other first and just engage it by one or two threads. Start the other one in the same amount. And now we're going to draw them both together by only turning the sleeve so that they'll be equidistantly drawn into the sleeve. We want to continue drawing the tie rod ends in together with the adjusting sleeve until it is the same length, pin to pin, as our original assembly from the vehicle. Now, we want to lubricate the pins for the tie rods and install our grease fittings and then install the tie rod assembly into the car. With the tie rod assembly installed in the vehicle, final tighten both nuts and install cotter pins. Now is a good time to pre-tighten the locking clamps until they just move snugly about the sleeve. Before reinstalling your anti-roll bar, lubricate the inside area of the mounting bushings. With the bushings and brackets attached to the sway bar, remount the bar into the chassis, but do not tighten until the end links have been installed in position. With the sway bar loosely mounted to the chassis, we want to install our link bolts. First, install a washer and a bushing on the link bolt then the link bolt is installed going up through the bottom of the lower control arm, followed by another bushing, a washer, the distance piece, a washer, a bushing, through the sway bar, and with a final bushing, washer, and nut combination. With both link bolts loosely installed, we can now do all the final tightening on the link bolts and chassis mounting hardware. Front end alignment consists of three major elements. These elements are caster, camber, and toe. The effective caster stabilizes the steering by causing the front wheels to line up in the direction of travel. Camber is used to direct most of the vehicle's weight onto the larger inner front wheel bearing and to place the point of pivot of the tire as near the center of tread width as possible. Toe is used to compensate camber angle to limit tire wear. Now, let's take a look at our front suspension and see what these three elements look like. This is a head-on view of our visual aid indicator. Take note that it is vertical, being perpendicular from the floor. If we look beyond the indicator, we'll notice that the center of the lower ball joint, the center of our spindle, and the center of the upper ball joint are all in line with this indicator. This would dictate a zero caster condition. As we move our upper ball joint behind the spindle toward the rear of the car, this would be typical of a positive caster condition. Consequently, moving the ball joint forward ahead of the spindle will indicate a negative caster condition. We're going to now move the control arm first to the positive, then the negative condition, and you will see the change in relationship between the spindle and the upper ball joint through our vertical indicator. In this view, we'll notice that the relationship between our vertical indicator and the upper ball joint has changed. The ball joint is now toward the rear of the car, indicating that it is behind the spindle center line, as shown by the indicator. This shows a positive caster condition. Consequently, the opposite is also true. With the upper ball joint moved forward by pivoting the upper control arm on its mounting studs with the shims, we can now clearly see that the upper ball joint is ahead of the spindle by reference to our vertical indicator. This would dictate a negative caster condition. In this view, our visual aid indicator is now perpendicular to the floor in this attitude. We have added a level to our indicator to clarify this. In this condition, we're indicating the fact that our spindle is now parallel with the floor. In this position, we'd be in a state of zero camber. If we move our upper control arm in toward the center of the car, it'll raise the outside of the spindle up. We'll see on our indicators that this would dictate a negative camber condition. Consequently, by moving the upper control arm out away from the center of the vehicle, it'll move the outside end of our spindle down, and this would indicate a positive camber condition. As we move the control arm to a negative condition and then a positive condition, you'll see the change on our indicator and level. In this position, our indicator tells us the spindle's moved up on the outer end, which indicates negative camber. The opposite is also true. Moving the upper ball joint out from the center line of the vehicle, we have dropped the end of our spindle down, and our indicator shows we're in a positive camber condition. To understand toe, let us assume that this indicator represents the longitudinal center line of our vehicle. To experience zero toe condition, the length of our spindle will be perpendicular to this center line. If our spindle is less than 90 degrees from the rear center line of the car, we'll be experiencing toe out. With the spindle being less than 90 degrees to our front center line, we'll be experiencing a positive toe condition, or toe in. Right now, we're at a zero toe condition. We're perpendicular to center line. This would indicate an extremely toed out condition. Consequently, this is an exaggerated toe in condition. After assembly is complete, we'll then show you how to square the steering linkage, set toe, and set adequate camber alignments so that you can safely drive your vehicle to a shop for a final alignment. With the vehicle back on the floor, we want to roll the vehicle back and forth several times while pushing up and down on the bumper to settle the suspension. Once the suspension is settled in, we can check our camber. To check our camber, we're going to take a level, use it as a straight edge across the face of the tire, and read the bubble. We want this reading to be as close to zero as possible. If we're not at zero, we want to adjust our reading by the addition or removal of shims in the upper control arm. If at all possible, we want to add or remove the same amount of shims on both the front and rear attaching bolts of the upper control arm simultaneously. Once we have arrived at a near zero reading, our camber is satisfactory for this initial alignment. Now we can proceed to check and adjust our toe. To square the steering linkage, we must measure from the center of the pitman shaft to the relay rod at the end of the idler arm, and then from the idler arm shaft center across to the pitman arm end of the relay rod. Once these dimensions are identical, the steering linkage is said to be in square. Now we must mark this relationship on our steering shaft and the steering box. With the steering linkage measured square, we want to put reference marks on the steering shaft and the steering box. These marks should be in alignment while setting toe. Notice the mark that's moving has been applied to the steering shaft from the steering wheel, and the fixed mark is on the steering box. Once again, these marks should be in alignment while toe is being set. In order to check and set toe, first, using your floor jack, lift the tire off the ground just high enough so the tire can turn freely. We want to use the jack under the lower control arm so as not to upset the suspension travel any more than necessary. Next, we need a scribing jig. To do this, we've taken a 2x6, drilled a hole, and inserted a sharp pick. This will allow us to put the tool in this position while engaging the tire with a sharp end and accurately mark our tire. By marking the tire, we're actually referencing a line that is perpendicular to the spindle. We move the tool into place and engage it lightly in the tire, hold it tightly in place, and slowly rotate the tire. This will scribe an accurate line all the way around the full circumference of the tire. To make sure you've done an adequate job, remove the tool, rotate the tire, and make sure that your line runs true and doesn't wobble back and forth. Now we need to repeat this procedure on the other front wheel. With both tires scribed and the vehicle back on the ground, we now need to resettle the front end the same way we did while doing the camber check, with one change. While settling the front end in, we also need to realign the marks on our steering shaft and steering box. Once this is complete, we can now accurately check and set our toe. To measure the toe, we must measure the distance between the left and front tires on the scribe line in the front and the rear of the tires. We also want to measure the tires at the same height from the floor. To do this, we're using these cans or any similar device of equal height. Now we just need a tape measure and actually measure the distance between the scribe lines at the height of the cans. After recording the dimension between the front of the tires on the scribe lines, we must repeat the procedure on the rear of the tires and compare the front and rear readings. If the rear reading is longer than the front reading, we are in a state of toe in. In other words, the front of the tires are closer together than the rear of the tire. If the opposite is true, the rear reading is less than the front reading, we're in a state of toe out. Regardless of toe in or toe out, we want to adjust the front end till we arrive at 0 or approximately 1/16 toed in for this initial alignment. We adjust the difference in toe by turning the adjusting sleeves on our inner and outer tie rod assemblies. We want to make changes to both tie rod assemblies at the same time in equal proportions. When we've arrived at our desired toe, we know we've done the job correctly when both tie rods are almost exactly the same overall length while our steering is squared on our reference marks. Also, between each adjustment of the tie rods, we must resettle the front end back in to allow the adjustments to take effect. Before driving off, there are 6-point checklists you must run through. 1. Make sure that the upper control arm to chassis mounting points are tight. 2. That you did your final tightening on your upper control arm shaft nuts. 3. Lower control arm to chassis bolts should be thoroughly tightened. Once again, the upper and lower control arms should be final tightened with the vehicle at ride height. 4. The adjusting sleeve clamps on both tie rods should be final tightened. 5. All cotter pins should be installed. 6. All pivots should be lubricated. The Chrysler torsion bar suspension varies in many ways from the double A-arm suspension we've just been working on. One of the obvious differences is the construction of the lower control arm, which is actually consisting of 2 major components, that being the actual lower control arm and the strut rod that reinforces it and helps maintain its location in the vehicle. Looking at the lower control arm from the rear of the vehicle, we'll notice another major difference in this type of suspension, the torsion bar. The torsion bar takes the place of the coil spring that we looked at in our previous suspension. It controls the weight of the vehicle by preloading from a tension screw and the twisting action brought upon it by the upward and downward travel of the control arm. That is why the torsion bar is mounted to the center pivot of the lower control arm. The rear of the torsion bar is mounted in a fixed socket in a cross member further back in the chassis. The last major difference in this type of suspension is the fact that the upper control arm adjusts caster and camber through eccentric cams instead of shims. To remove the torsion bar, we must first raise the vehicle, supporting it with a pair of safety stands, remove the shock absorber, which allows the lower control arm to drop a little further, removing tension, back off on the tension screw, making sure that we count and record the number of turns necessary to remove all the rest of the tension from the torsion bar. Once this has been accomplished, we remove the retaining clip from the rear of the torsion bar and slide it toward the rear of the car out of the lower control arm socket. Now the remainder of the front suspension can safely be removed from the vehicle. The early Chevrolet Nova suspension, pictured here, is almost identical to that of the early Ford Mustang. They are both very similar in component structure to to that of the Chrysler torsion bar suspension in that they share the lower strut, strut rod, and upper A-arm. However, they vastly differ due to the fact that they use a coil spring over the upper control arm instead of the torsion bar, which worked off the inner pivot of the lower strut. The Chevrolet also differs in that camber is adjusted using an eccentric cam on the lower strut inner pivot, and caster is adjusted by use of a threaded strut rod. The Ford Mustang suspension uses shims on the upper control arm to adjust caster and camber. To safely remove the coil spring from this type of suspension, we first must remove the shock absorber and this steel framework. Once that is removed, we can install the proper type spring compressor, which in this instance is an external type that's made up in 2 units. We compress the spring just enough to relieve all its tension from the mountings and remove it from the vehicle, after which the remainder of the suspension components can be removed, rebuilt, and reinstalled. Third generation Camaros, Firebirds, and Mustangs all share the same type of front suspension. These suspensions are similar to the double A-arm coil spring type suspension in that they use a lower A-arm and a coil spring which works with the lower A-arm. It differs in that it uses a strut shock absorber in place of the upper control arm, and that caster and camber is adjusted by moving the top of the strut. On this type of suspension, you can use either an external or internal spring compressor. A final word on safety. If you are not familiar with jacking and supporting a vehicle, always refer to the owner's manual or shop manual for the vehicle that you're going to work on for this information. Always use supports that were designed specifically for this type of work and use them in pairs. And by no means ever substitute these supports with things like cinder blocks or stacks of wood. Also, don't forget to final tighten all fasteners and make sure all cotter pins have been installed before driving off for your final alignment. Thank you very much for your time, and we'll see you down the road.
Brought to you by PST with its exclusive line of polygraphite suspension components. Call 800-247-2288 to receive your free PST muscle car catalog.